Most people think you need massive enterprise servers to build a serious home lab. But what if I told you that you could pack an entire cluster of compute nodes running containers, automation, and services inside a compact rack powered entirely by ARM-based SBCs? In today's video, I'll show you my dream home lab build, an ARM-based Docker Swarm cluster all running over PoE, housed in a custom 3D printed rack mount system. And here's the best part. I'll be sharing the 3D print files for free so you can build your own. Traditional x86 servers are powerful, but they're also noisy, power hungry, and overkill for many home projects. ARM single board computers, think Raspberry Pi and alternatives like the Rock Pi or Orange Pi boards, deliver efficient, scalable compute power in a tiny form factor. By clustering them together with Docker Swarm, you get distributed compute that's perfect for self-hosting services, experimenting with cloud-native apps, and running real-world workloads, all with a fraction of the energy and noise. And because each board is powered by PoE or Power over Ethernet, there's no more messy wall of power adapters, just one clean network cable per node. Also, if a node in the cluster ever locks up, and let's face it, that happens, I have the flexibility to remotely power cycle the affected switch port's power to bring the node back up without any physical intervention. So let's talk hardware. At the top here, we've got a managed PoE switch. This is the lifeline of the cluster, delivering both networking and power to every node. Below that is the star of the show, a set of 3D printed rack mounts designed to hold each board in a blade-style hot swap format. In a 2U space, it houses 10 nodes. Each blade slides into place with its own SBC, heat sinks, and ports accessible right from the front. If a node fails, I can pop it out and drop in a replacement in seconds. No tearing apart the rack. I like to use these third-party PoE injectors rather than the board-mounted PoE hats. They have a few important advantages. First, they're cheap. Check the link in the description below. They come in a variety of formats, providing USB-C or micro USB power outputs, depending on what board you're using, and a variety of power capacities. All of them will properly pass through Gigabit Ethernet. In this blade style format, you can see that they do not add any thickness to each node, which is important. We have plenty of depth to work with in this format. As you can see as well, some SBCs like these Rock 4s here have the processor on the back, therefore the heatsink as well, so adding thickness to the front of the board really wouldn't be ideal. In the case of my Raspberry Pi 5 here on the end, which is my home assistant, I am using the more traditional hat-style PoE board. And finally, we've got the supporting hardware for the cluster, additional high-speed storage for persistent volumes, and a UPS for clean power backup and airflow panels to keep everything cool and quiet. This journey was a build in and of itself. First came the 3D design work, measuring the SBCs, testing tolerances, and prototyping until the blades were a perfect fit. Then printing each module and assembling them into the rack mount system that looks and functions like a professional blade chassis. The actual unboxing and setup of each SBC is simple. Just connect the PoE adapter to the power and Ethernet ports and slide it into place. Cable management stays nice and neat because it's just one cable from each node, providing both power and networking. And finally, that first power up, watching the entire cluster light up over PoE, each node coming online, ready to join the swarm. Hardware is only half the story. Once the SBCs are racked and powered, it's time to bring them to life with Docker Swarm. And that cluster automatically balances workloads across nodes. I can deploy services like Plex, Home Assistant, VPNs, distributed video encoders, project management software, web servers, monitoring stacks, and Docker takes care of all of the distribution. If one node goes down, the others pick up the slack. The beauty here is in scalability. Need more compute? Just 3D print another blade, drop in another SBC, it instantly joins the cluster, boom. It's modular, efficient, and insanely flexible. So what does this setup deliver right away? Reliable automation, flexible self-hosted services, and a lab environment that rivals small data centers. All powered by affordable, low-powered ARM boards. And the best part, this system is designed for growth. As ARM boards evolve with more cores and faster networking, I can slide them right into the existing rack. The 3D printed system makes future-proofing effortless. And because I believe in the community and open sharing, I'll be making the 3D print files available for free. So you can build your own blade-style rack and start your own Docker Swarm cluster at home. If this gave you some inspiration, hit like, subscribe for more deep dives, and grab those 3D print files in the description down below. I can't wait to see what you build. Thanks for watching, and I'll see you in the next one.